Hello everyone, welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are working on Chapter 3, Lesson 3. By the end of the lesson, you should be able to solve word problems involving comparisons. There are no new terms for this lesson, and we are going to begin with our first example. The Center City Animal Hospital treated a total of 18,360 dogs and cats last year. The hospital treated 1,376 more dogs than cats. How many dogs were treated? How many cats were treated? Remember our strategy where we focus on figuring out which unknown is based off of the other. Which one do you have to know first in order to figure out the other? In order to figure this out, we're going to focus on the second sentence that says that the hospital treated 1,376 more dogs than cats. That tells us that we have to know cats first because the number of dogs is based off of the number of cats. So we can write a let statement that says let C equal the number of cats. You can choose any variable that you want to. You do not have to use the letter of C. I just chose C. And then we're going to write a second let statement that's going to represent the number of dogs. Now remember that you have to write your let statement in terms of C, and it needs to be representative of your dogs. So there are 1,376 more dogs than cats. So if we have C number of cats and there's 1,376 more dogs, more than means addition, we have 1,376 more, so that means we're going to be adding. And then they told us in the very beginning of the problem what the total number of dogs and cats that were treated were. When they give us a total, that means that the number of dogs and the number of cats were added together. So cats added to dogs totaled 18,360. You can now combine like terms. C plus C makes 2C plus 1,376 equals 18,360. Subtract 1,376 from both sides. 2C equals 16,984. Divide both sides by 2, and we would find that C equals 8,492 cats. Please remember that C represented the number of cats. The problem also asked us how many dogs were treated. So in order to figure that out, we have to take our 8,492 cats. 8,492 cats. And that has to get added to, if you look at our let statement for dogs, 1,376. When you combine and do that addition, we will get 9,868 dogs. So the very last step would just be to write a sentence that incorporates that together to answer your final question. And you can just say something as simple as, there were 9,868 dogs, and I'm just going to use that number I already wrote there so I don't have to write twice, 8,492 cats. Example 2. A deckhand on a fishing boat is working with a rope that measures 89 feet. He needs to cut it into 2 pieces. The long piece must be 17 feet longer than the short piece. Find the length of each piece of the rope. We need to figure out which piece depends on the other. Is it the shorter piece or the longer piece? What do you think? The problem tells you that the long piece must be 17 feet longer than the short piece. You must know the length of the short piece first. That tells you that the long piece is depending on the short piece. So then our short piece must be the one that we find out first. So our short piece is going to be our independent variable. It is our x. And then our long piece is our dependent variable. It depends on the length of the short piece. It is 17 feet longer than the short piece. That indicates addition of 17. If I take my short piece and my long piece and put them back together, it's going to equal a total of 89 feet. So the short piece is x, the long piece is x plus 17. So when I add them together, that gives me the 89 feet. X plus x is 2x plus 17 equals 89. We're going to subtract 17 from both sides. 2x equals 72. Divide both sides by 2. And x equals 36. Now remember, x represented the short piece. We can now use that piece of information to help us find the longer piece of rope. So x plus 17 was the expression that we wrote to find the long piece of rope. So 36 plus 17 gives us 53. So the long piece was 53 feet. And the short piece was 36 feet. Please go ahead and read example 3. I would like you to go ahead and try this one on your own. Pause the recording, solve the problem, and as soon as you're ready, please play the recording and we will solve it together. Okay, by now you should have had an opportunity to solve this problem on your own. The problem said that an airport filed a report showing the number of plane departures from the airport during each month last year. The number of departures in March was 50 more than the number of departures in January. In July, the number of departures was 150, less than triple the number of departures in January. In July, the number of departures was 150. I lost my place in the problem, I'm sorry. I'll start at the second sentence again. The number of departures in March was 50 more than the number of departures in January. In July, the number of departures was 150 less than triple the number of January. In those 3 months, the airport had 2,250 departures. How many departures were recorded each month? Now, since the problem told us that March was dependent on January and July was also dependent on January, that should be an indication to us that we have to allow the month of January to be our independent variable. So we're going to allow X to be the number of departures in January. And after that, we can focus on writing an expression in terms of X for both March as well as July. So the problem told us that in March there were 50 more than January. More than indicates addition, so we would say X plus 50. And in July, there was 150 less than triple. So we're going to triple January, but then there was 150 less than, which indicates subtraction. So we have 3x minus 150. They also told us that there was a total of 2,250 departures combined for all 3 months. So that means that I need to take January plus March plus July, and that total was 2,250. Well, what did we use to represent January? We used X. We need to add that to whatever we used for March. We used X plus 50. And we need to add that to whatever we used for July. We used 3x minus 150. And that's all going to equal 2,250. When you write organized let statements the same way that we have, it helps you to write your equation. I hope that you see that from what I'm doing here in the work. We can now write we can now combine like terms. X plus 3x is 5x. 50 minus 150 is negative 100, so I'm going to write my minus 100 and bring down my equals 2,250. We're going to add 100 to both sides, and 5x equals 2,350. Divide both sides by 5. X equals 470. Now please be reminded that we are solving for all 3 months, and the plain old X represented the departures in January. So in January, there were 470 departures. In March, we have to solve for that using our expression. March had X plus 50, so we're going to take 470 plus 50, and we will get 520. So March had 520 departures. And lastly, we have to find July. July, we have to use the expression 3x minus 150. So we will take 3 times our value for x, which was 470, minus 150. When we evaluate all of that math, we should get 1,260. So we should find that there's 1,260 departures in the month of July. Lastly, you would finish that off by writing a sentence that summarizes, organizes, and answers the question. And your sentence should simply say that in the month of January, there were 470 departures. In the month of March, there were 520 departures, and in July, there were 1,260 departures. Example 4, another problem very similar to the one that we just did. Please take a minute and set it up and solve it. You can pause the recording and press play as soon as you are ready to go over the answer with me. Okay, by now you should have solved the problem on your own, and you should be ready to review the answer with me. The problem says that a social services worker was comparing the cost incurred by 3 families in heating their homes for the year. The first family had an annual heating bill that was $360 more than the cost of the second family. The third family had a heating bill that was $200 less than double the heating bill of the second family. The total annual heating bill for the 3 families was $3,960. What was the annual heating bill for each family? As you were reading through this problem, you should have seen that the first and third families' values were both based off of the second family. So we're going to let x equal the second family's bill. And then from there, we can write let statements for the first and third family's bill. So the first family had an annual heating bill that was $360 more than the second family. So the second family's bill was X. More than means addition, so we have X plus 360. The third family's bill was $200 less than double. So first we have to double the bill of the second family, and then we have 200 less than that, so that indicates subtraction of 200. Now that we have the let statements for each family written, we can go ahead and put together the equation. So we know that the first family plus the second family plus the third family all totaled $3,960. So at this point, we can simply take the expressions that we wrote for each family and substitute them in. The first family's expression was X plus 360. The second family's expression was X, and the third family's expression was 2X minus 200. And the total is still 3,960. We will combine like terms. X plus 2x is 4x. 360 minus 200 is 160. And then we will bring down the equals 3,960. We have to subtract 160 from both sides. 4x equals 3,800. Divide by 4, and x equals 950. Now keep in mind that x represented the heating bill for the second family. We must now go back and find the values for the for the first and third family as well. So the first family's expression needs to be found by taking x plus 360. So 950 plus 360 equals 1,310. And the third family's bill is found by doubling our 950 and then subtracting 200. And that value works out to be 1,700. So now you're going to write a sentence that tells me that the first family's bill equals $1,310. The second family's bill equals $950. And the third family's bill equals $1,700. Example 5 has us working with a small plot of land that's in the shape of a rectangle. So we're dealing with length and width and perimeter. Please go ahead, take a minute to work on this problem. Pause the recording. When you're ready, hit play and we'll go ahead and solve it together. Okay, by now you should have had an opportunity to work out example 5. As you're reading through this problem and it tells us that the length is 7 meters longer than the width, that's an indication that length is based off of width. So that means that width needs to be our starting point. So we're going to go ahead and let the W equal the width. And then we have to write an expression for the length. It says that length is 7 longer than the width. Longer than is an indication that we're working with addition. So we're going to add 7 to that length. Length, sorry. Now, when we write our equation, we're going to work with the perimeter formula. Perimeter formula for a rectangle is P equals 2L plus 2W. So they have given us the value for the perimeter, so we're going to substitute in 86 for P. We're going to substitute in our expression for length, which was W plus 7. And then we're going to substitute in our value for width, which was W. So our W actually doesn't change. And now we're going to rely on all of our equation solving skills to solve the rest of the problem. We must distribute in. So we're going to have 2W plus 14, and then bring down our next 2W. Combine like terms. 2W plus 2W makes 4W, and bring down the 14. Now we will subtract 14 from both sides and get 72 2, equals 4W, and divide both sides by 4. 18 equals W. That tells us that our width was W because looking back at our let statements, W represented width. In order to find the length, we must use the statement W plus 7. So 18 plus 7 gives us 25. So that means that the rectangle that represents the plot of land was 18 by 25. So the rectangle was 18 by 25 meters. Okay guys, we have one more problem to do for this section, and it is example 6. It's very similar to the one that we just worked on, so I would like for you to go ahead and work on this one, please. Pause the recording as soon as you are ready. Play the recording and we will go over the answer together. Okay, by now you should have had an opportunity to solve example 6. The problem tells us that a farmer is going to enclose a pasture with fencing. So the first side of the triangular pasture is 30 meters less than the second side, and the third side is 1/2 as long as the second side. What you should have concluded is that our starting point is the length of the second side because both of the other two sides are based off of that second side. So we're going to go ahead and let x equal the second side, and then we can write let statements that represent the first side and the third side. So back to the problem, it says that the first side is 30 less than the second side. So we can write x minus 30. And the third side is 1/2 as long. So 1/2 of x would look like that. So when I put all three of my sides together, there's going to be 720 meters of wire fencing. So that means I'm going to have x minus 30 for my first side, added to x for my second side, added to 1/2 x for my third side, and that's going to equal 720 meters. So now I can combine like terms. X plus 1/2 gives me 2.5. I'm going to use a decimal. 2.5x minus 30 equals 720. I'm going to add 30 to both sides. 2.5x equals 750. Divide both sides by 2.5. And x equals 300. So that tells me that the second side of that triangular pasture was 300 meters. But I have to find the other two sides as well. So the first side was found by subtracting 30. So 300 minus 30 is 270. And then the third side is found by taking 1/2 of 300, which is 150. So the last thing that you want to do is go ahead and write me a nice little organized sentence that tells me that the first side of the pasture is 270 meters. The second side of the pasture is 300 meters. And then the third side of the pasture was 150 meters. If you find that you have any questions at all from this section, please let me know. As always, I will be more than happy to work through anything with you. Just contact me through email or through the discussion board or whatever you feel most comfortable with, and I will be more than happy to work with you on this section. Thanks.